Hello everybody. In this day and age where governments and corporations are spying on you every day, 24/7, it is very, very useful to know about how to communicate securely such that no entity can ever decode your messages to some other person. I mean, who knows what happens in the future? Maybe everything will be anarchy. And in that case, it's very, very useful to be able to, communicate in a way that nobody can decrypt your stuff. So how do you protect messages? In Linux, there's a very nice built-in tool, at least in Ubuntu there is, and that's called GPG. That is a software for encoding or for generating keys, a private and a public key pair, and then automatically applying those keys to messages and sending them to recipients and decoding the messages that you received, etc. So assume, for example, you find someone on the internet that you want to message. For example, let's go to my website, and I have this link here, which is a GPG page. And here I specify a code. There are many developers online and many people online, or non-government organizations, or maybe even government organizations where you can whistleblow something, which supply a PGP key. And you can just copy that key, paste it into your Linux software, and then use that public key supplied by whoever you want to send messages to encrypt your stuff. And then only the person who owns that key, who owns the private key that belongs to that public key, can ever decode your message. So the public key is for encoding stuff. Everybody can use this key to encode stuff, but only one person who owns the private key that corresponds to this public key can ever decode your messages. And that is very interesting. So let's have a look at how that is done in Linux. So there's the software GPG. Nothing happens if we just execute this command. By the way, I'm not an expert, so we have to find stuff out together a bit. I tested it yesterday, but maybe I will need to refresh my memory. So GPG help. Let's see what it says. So this is the GPG software right here. You can do lots of stuff, encrypt keys, you can verify signatures. Okay, I just wanted to point to the decrypt data stuff. And of course, we can also create a new key somewhere. Where is that? Generate key. There's a generate key option. So let me just do that. GPG generate key, and we will generate a new key. So what does this software ask me to do? It asks me to supply my real name. Of course, if you want to be anonymous online, then you can enter whatever your fictional name is. But in my case, it's Daniel Hirsch. My email address is contact@hirschdaniel.com. Then this is now composing my user ID, my full name and email. You can use whatever information you want. This is just information that is going to be embedded in the public key. So inside this public key block right here, your real name and email will be embedded. And the reason is that when you import this key into your GPG software, then it creates kind of like an address book with names and emails and the associated keys. And then you can say, I want to send a message to this email. And then it automatically fetches the key belonging to the email. And then you don't have to pick the keys by hand and manage who they belong to. The software does that for you. So that's why you embed the user data in the key. I hope I don't tell you anything wrong here. So if you are familiar with PGP or GPG and I'm telling you anything wrong, then please correct me in the comments. But this is my understanding of it. So now we have the option to change either name, email, or we can confirm it using OK. So let's do that. And now I can I can create a passphrase that will protect the locally stored keys on my disk. Or to be more precise, this will protect the locally stored private key on my disk. So the private key is the secret that you personally own to decrypt all the messages sent to you. Okay, so if you have the private key, you can decrypt all the communications to you, all the messages sent to you that are encoded with your public key. But if someone, for example, let's say your house is raided, I don't know what you do, and I don't want to assume anything. Let's say you're a criminal and your house is raided. Then someone oops, there's a timeout. Let's say you're a criminal and your house is raided. Then someone can get your hard drive. It can just unmount it from your computer and then get that file and then decrypt all the secret communications to you. So that's not what you want. That's why you also supply this passphrase to encrypt the private key stored on your disk. So let me just re-enter all the information here. Okay, and my passphrase. And here it is very useful to pick something long because that is the real security limitation here. If someone has access to your encrypted private key, well, then the longer the passphrase, of course, then the harder it is to decrypt it. Okay, so I'm going to pick this one. Ah, damn it. Okay. Please enter the passphrase. Okay, let me re-enter it. Why does it not accept my passphrase? Damn it. Let me just try another one. Maybe something is wrong with it. Okay, this one was fine for some reason. And here, this is something interesting. Let me just highlight the text here. During the generation of the key, there's a printout that says we need to generate a lot of random bytes. That is the private key. It has to be a random key from it has to be a very, very random key. And they have to generate a lot of bytes. It is a good idea to perform some other action. For example, typing on the keyboard, moving the mouse, or utilizing the disks during the prime generation. So during that 1 second that this key generates, you should wiggle your mouse or do whatever on your computer. But I don't know if it's really that critical. But it gives the random number generator, as the text says, a better chance to gain enough entropy. So that is that improves the capability to generate a truly random number. But anyways, okay, so we have now created a key, and this one right here, we have created a public and a secret key, the private key, public and private key. Now, this key has a user, it's associated with a user ID and has an expiration date. I think if you use another option, let me just look that up. There should be there's also the full generate key. There you can also adapt the expiration date and set it to expire never, and you can even choose the encryption algorithms and stuff like that. We don't need that for now. We just use default settings. So what can we do now? We can list keys. GPG list keys. And I have got a couple of keys in my storage here because I tested the software earlier. So first of all, I generated a key yesterday and uploaded it to my website. That's the one that you see that is available there. Then I found another developer who also supplied their key on their website, and I imported that key. And the software even filled the name and the email. And then I generated in this video, just now, a new key. So I have 3 keys in my storage now. So what can we do with those keys? Let's say I want to send a message to myself. Then I can, well, where is it? I guess I want to encrypt data then, in that case. So let's just create data for now. So let me open a file in Vim. And let's do this. Just a couple of interesting signs. This is the secret data. My secret is what is my secret? Have a small pen. Then let's complete that with a couple more characters here and save that file. Now let's try to use encrypt. And then let's supply the data.txt file. And now it asks me enter the user ID. What is the user ID? I want to send to contact@Hirsch-Daniel, but I actually have two of those imported, so I'm not sure if that's which one it takes. Current recipients. It takes the one that I generated yesterday. Wait, let me just list the keys again. Why does it take by default the first one? That's actually a good question. Encrypt data. Let's encrypt again. I did not specify a user ID. Current recipients, enter the user ID. Okay, that means I can specify the recipients with encrypt. Let's see if there are any options with encrypt that I can use. Local user ID. There's a user ID that we can specify and a recipient. It's always great when a video is not completely prepared and I have to deal with real-time stuff here, real-time problems. Let's say I want, what do I do if I want to encrypt the last user ID? List users. No, GPG. This is the shortcut for keys. UID. Daniel Hirsch. Can I just pick this key right here? Let me just highlight that and copy it. GPG help. Recipient local user ID. Okay, let's try. GPG encrypt. Local user, then let's paste that ID, data.txt. Nope, that is not an identifier for the local user. So let's have a look at what to do with duplicate users. GPG duplicate users. You can always use a key ID. Okay, so we can use that key ID. That means, let's try again. Let's just specify, instead of local user, the recipient. recipient, and then the key ID, data.text. Okay, and that worked. Great, very good. So now we have, as you can see, a data.text, which is the unencrypted text file that we created earlier. And then we have a data.text.gpg, which is apparently a binary file. See it anyways, yes. And that is the encrypted file. There's no chance on Earth in the entire universe you can... Let's say you are king of the universe and you have all the resources. I bet you have no chance to decrypt this. No way. Okay, maybe you have some slight chance to decrypt it because you saw... No, you don't. I just thought you have, because you have seen how long my passphrase is, you have a better chance of brute forcing it, but you still don't have access to my actual private key because you don't have access to my Linux machine. So no chance on Earth you can decrypt it ever. Okay, so now we have a secret file and we have an encrypted secret. And the encrypted secret is this is now a file that you can send to the recipient. Okay. Now, the recipient is the user that we specified. It's this user right here. Then you can send that file via email, for example, and that file is then received at contact@herrsteiner.com at the recipient's email, which is in this case mine. And the recipient has access to the private key because he has generated it on his machine. Yeah, good. And in this case now, instead of being the sender, now I switch to recipient mode. I am now the recipient. Let's do the following: GPG help, and there should be a decrypt option, which we saw earlier. Decrypt data. So let's try. GPG decrypt, and then we decrypt the GPG file. And I think we have to specify an output file, as you see up here in this line. And the output is decrypted data.text. Output is not considered an option. What does that mean? Decrypt data.text.gpg output date. Why? Write output to file. Okay, let's try without the output flag. Let's see if that works. Okay. Okay, now I'm asked to enter the passphrase to unlock the OpenPGP secret key. So I have received an encrypted file now on my machine, for example, via mail, via whatever. And that encrypted file was encrypted using the public key, which I made available online. Or to the sender. I made it available to the sender. Now I can enter my passphrase. Let's see. And let's confirm. Okay. Oh, and this is the secret. As you can see, this is now the decrypted data right here. Now, was this data written somewhere? It did just print out. Maybe we can pipe it into an output file. For example, decrypted data.text, just like this. And it was decrypted now. It didn't ask for the passphrase because I just entered it and it kept it in memory apparently. And here we can just check the decrypted data.text, and this is the secret data. Awesome. So that's how encryption and decryption in GPG/PGP work. Quite nice. Very, very important when things go wrong in society and governments fail and there's anarchy, or even when governments take too much freedom to do whatever they want with their citizens. In that case, you want to know how to secure your communication, and that's the way to do it. So, in summary, you generate a key for yourself. You enter your name and your email, or you enter whatever anonymous names you want to take on. Then you have on your local disk a public key and a private key. And the public key, you can just make it available to whoever you want to communicate with. You can make it available to anyone on the internet. The public key is something that anybody on Earth can use to send you messages. And only you have to keep the secret, the private key. And then anybody can send you messages, and you can decrypt those messages using your private key, which you kept private on your local machine. Okay, so one last thing before we close this video. How do we even make the public key available to anyone? Because right now we have generated something. We have generated keys locally on disk, have used them to encrypt data and decrypt them, but we have never seen the keys. So let's do that. I mean, we want to make the keys available to someone as well. So help, then we should be able to export keys right here. Let's see, GPG, export. Oh, damn it. This just exported whatever. Is there any more user-friendly way to do that? GPG export, maybe we have to specify the... Wait. No, I have to look it up. GPG export public key. You specify GPG export and then the email address, and then you pipe it into a public key output. Okay, in my case, I want to specify the ID of the key, this one right here, because I have two keys associated with the same name and email, so only this ID identifies the key. So let me just copy that key, GPG export, then that key, and then let's pipe it into public key.gpg. No, was it GPG? I think it was. And let's have a look at the public key.gpg. As you can see, this is now the binary data, and in the middle of it, you can see that there's the Daniel Hirsch user ID embedded into the key file. Now those keys are not as nice to put online because they are binary data and you can't really nicely represent it online on a website. For example, like on my website where I just supplied this nice formatted key block right here. This is a dedicated format to be imported by other users. And to do that, we can use the following command. We can use GPG export and then armor. And this should create another public key, which is now in this format right here. It starts with begin PGP public key block and then with an end clause at the end. Normally those armored public keys are meant for sharing, and they are stored with a different file format that is called .ascii, which stands for ASCII. Because it's now not binary data but encoded, I think it's base 64 encoded data that is now in this text file. So this is now a regular text file, and this public key can now be imported by anyone on their GPG instance. So let's have a look at how that is done. There should be an import option. It's actually quite simple. And let's search for import. There it is, import merge keys. So let's import this. Of course, this won't do much because I have already stored that user. Yeah, as you can see, this is a user already present and it's not changed. But maybe to complete this example, we can have a look at whatever entity that I can find online has or provides a GPG key that we can use to import it, just so that you see how the full process is working. So let's search for in-text GPG. Maybe like this. In-text or PGP, no. Let's search for this, begin public key block. Okay, and there's a website from some hospital, it seems. Yes, and this website specifies a public key block. So let's copy that key block. You can also download it. I just copy it, open it in Vim. Let's call it hospital. Let's call the file hospital public key.gpg or .asc because that's the format. And let me input all that stuff from the website. Let's save that and let's import that key into GPG. Hospital public key ASCII. And of course, don't forget the import option. And as you can see, I now have the public key from some doctor. Yeah, very, very nice. And now I can send this guy GPG encrypted messages. Now let's list the keys. As you can see, this is my new contact here. And now I want to send him a message, for example, doctor's note .text. Dear doctor, I have terrible nightmares. Please give me a doctor's note. Best regards, Daniel. Okay, so this is just my request for a doctor's note from this doctor, and I want it to be private. And now let's send him this message using GPG encrypt, and I specify his email vidcop@hz-ol.de. I did not specify a user ID, so it did not understand this contact for some reason. I did not specify the -r as it says here. So let me try again. Encrypt --recipient. And then I specify also the file, of course. Doctor's note.txt. And now I get a warning message. It is not certain that the key belongs to the person named in the user ID. If you really know what you're doing, you may answer the next question with yes. Yeah, it's also possible to somehow generate keys in a way that you can be sure that the key is from this person. There's some way to validate that, but I'm not really familiar with that. If you know, please put it in the comments. But for our purposes now, this is fully fine. Let's use this key. And now we have an encrypted doctor's note.text.gpg. Let's have a look at it. This is the encrypted message right here. And only the doctor can now decrypt this message. I can't decrypt it anymore because I don't have the private key associated with his public key stored on my machine. So the public key that he put on his website right here is something that only he can decrypt. And that's something very important to understand. So only he has the private key associated with this public key, so only he can decrypt it. Okay, and I guess this was already a very good start and quite complete start for now into GPG. So whenever governments collapse or whatever happens in the world, please come back to this video and have a look at it again and communicate with your family and all your peers and close ones like this. Then you can encrypt files using everybody's private keys, public keys, and send them the encrypted files, and then you're good to go. That's it for this video, and I hope you discovered something new, and I certainly did, and it was fun. So see you next time. Please stay subscribed and always be curious. Bye bye.